This lesson is on the fundamentals of C#. This is in no way everything that you're going to learn on you're supposed to know on C#. There's a lot more, but I'm trying to cover this as part of your app training program. I'm doing this because you can write apps, Windows Store apps and Windows Phone apps without C#, but then it helps to know C# because it will give you the full extent, the full capabilities that you need for you to write extensive apps using on Windows Phone or Windows 8. So today is the first part of 2 lessons that we'll be having on the fundamentals of C#. And in this lesson, we're going to create our first program in C#, dissect the code, know what we're doing, what the functions of the elements that are present are doing. We're going to learn how to declare variables and assignment statements. We're going to do type conversions, explain what statements and expressions are, take a look at iteration statements like the for loop, then create arrays of values and take a brief look at methods. The part 2 would be mostly on object-oriented concepts. Since C# is an object-oriented programming language, we'll use the second part that would have a Monday to talk about C# as an object-oriented programming, where we'll look at classes, methods, inheritance, polymorphism, etc. So now we're going to start. Let me open Visual Studio. At this point, I'd like to stress that you need to have Visual Studio to be able to follow. So in Visual Studio is the integrated development environment that we're going to be having most of our sessions. I'm going to give you a brief overview of the development platform so that you know how best to work with it. So even after this lesson, when you're rewatching the videos or going through the blog post, please make sure to type as I type. I know for this lesson most of you would be watching, but when you're practicing on your own, please make sure to type, because the best way to learn a programming language is by actually getting your hands dirty with the typing. Even when your brain forgets, your fingers would know exactly what you wanted to write, and that's the kind of attitude that you'd want to adopt if you want to write apps and start programming. So when we open Visual Studio, we'd first want to create a new console project. We're going to use the console as the output medium for our apps. We're going to use it to display our results and our computation. So to create a new project, there are a variety of ways, but the one I like best is to click File, go to New, click on Project. Now here you would find that there are a lot of options here. So under Visual C#, there are a lot of options, and when we come here we have other options that we can choose, but we're going to be using console applications since that's the best way to go about teaching a programming language. So let's name this Hello World. Okay. And this would create the things that we'll need for our training. So here, don't worry about any of this, I'll explain them soon enough. So let's create our first program. We're simply going to write something that would display text to the screen. Don't worry if you don't understand any of this now, I'll explain it. So here I've written 2 lines of code, and what this does is, let me go ahead and run this. To run your code, you just need to click on this play looking button up here that says start. Click OK. And you can see in my console window that is displaying the text that I wrote for my console to display. There are many ways to get stuff done wrongly. That's okay. When you're writing your code, there are some rules that you need to follow, some doctrines that are accepted. Imagine if I took these lines of code, cut them here. I run them. I'll get a warning that there are build errors, and if I click no and I go to my error list, I have explanations as to why my code wasn't running. Here it says system.console.reline is a method, but it's used like a type. It says that invalid token parentheses in class struct. Usually when you get these types of errors, it means your code is placed somewhere that it doesn't need to be. So you need to look at it and change where it is. Usually with errors, as they're described in the error list, as you just saw, they explain how you're getting that error so that you can fix it. Imagine if I took out this semicolon here and tried running it. It will say no and write semicolon expected. Most of the time, there are some errors you'd get. You read them, but you still don't know what to do. And for these ones, you can easily go online, type in exactly what is type in exactly the error you're getting, and you see there is somebody out there who has gotten that same error in a forum somewhere that you can find a solution to. There are a lot of code forums for programmers out there. So getting stuck somewhere isn't really the end of the world. When you get stuck and you find your way out of that hole, you will learn a new thing. So please try and get your hands dirty. So the IDE, that's Visual Studio, manages the files required to write applications. It provides feedback on what you're doing and pop-up windows that explain your errors, that as I've just displayed. So in your effort to start app development, I'd advise that you learn a lot about C# in the coming weeks extensively. The idea is to learn one language, master it, and if you want, you can learn another language on top of it. That's when you are a master in one language, because most of the core concepts in programming languages transfer to other languages. So C# is made up of two core parts. That's the .NET framework class library and the common language runtime. The .NET framework class library is a library of code Microsoft wrote for programmers to borrow and use for their applications. That is code that is to take care of difficult tasks, such as using map libraries, code to display text on a screen, like this console.writeLine expression that we have here. If we wanted to write the actual code that would bring up this console window, this particular window, we'd have to write a whole lot of code. But then in the .NET Framework class library, all of these have been written for us, and we can easily refer to them and make use of them. Now, the common language runtime is the protective bubble in which your application runs inside of, providing access to important services. The .NET Framework runtime takes care of low-level details such as how your application interacts with the memory, making sure that your application doesn't crash somebody's computer. So imagine if this wasn't there. This would mean that if I am to write some kind of hazardous application right now and send it to somebody, the person can run it and it will crash their computer. So that's the function of the common language runtime. It protects computers from the code that people write, and people write some really hazardous things out there. So our application runs inside that bubble, and this runtime is responsible for taking care of all the low-level details that we need not to know about. Console.writeLine, as I said, is used code that is available in the .NET Framework class library. We just pass what we want displayed, and we don't want to know how it works. We just want our data displayed on the screen. You can see curly braces here, and these curly braces are usually they are used to define a block of code, that is a series of containers. So this curly brace here is the container for this main method. This curly brace here is the container for the class program. This curly brace here starts here and ends at the bottom is the container for everything in the namespace. This is the main method, and as you can see, the name here is main. This is the main method. And this method is a special method that is triggered every time your application runs. The main method lives inside a class, that is the class program. And the class also lives inside a namespace. Can you all see my screen? Sorry about that. Sorry. So, okay, for now, let's think of classes as an organizational structure. This is a high-level definition of a class. So the main method lives inside a class, and I'll define a class as an organizational container for your methods. You put related methods inside a class. See, you have a class called automobile, where in the class you have methods that execute code for getting your fuel limit, getting your acceleration, getting your your engine temperature, etc. Classes live in namespaces, yet another way of organizing code. At this point, high-level explanations of these things will be able to give everyone a good idea of what's happening before we take a deep dive into what these things actually do. Here we are executing a method called WriteLine that is contained inside the console class, which is part of the framework class library, that is borrowing the code that's available to us. This period here in between console and WriteLine is known as a member accessor, which means that in this class console, we want to access its member, that's the method WriteLine, and use it to display text to the screen. The parentheses, that's the brackets here, are used to invoke or execute a method. Methods can be defined to accept arguments, that is, input parameters that are used in the body of the method's code. If you don't understand this, we'll have a brief overview of methods before this class ends. So if you're confused, I'll explain all of these things in detail later on. So the double quotes here tells C# that we are passing a literal string as parameters. So if I check here, it says that this is part of the class system.string, and double quotes is used to do that. A semicolon is a statement terminator. We can have this line of code here, put it here, and this application will still run correctly because we have told the compiler that this statement has ended and this one is beginning. But for readability, we like to separate each statement and put it on a different line. If you like, you can write everything on one line, nobody really minds. But then if you look at your code tomorrow, can you be able to differentiate what this is doing and what that is doing? You should also notice the indentation here. Indentation, line breaks, and code coloring. Here you realize that our program here has a different name, our classes have a different color. So the console class has a different color, the program class has a different color. All of these things are provided so that you can easily look at your code and understand what you're doing. Notice the tabbed area here. Here we have the name of our solution we created, that's Hello World. Here we have the name of our project called Hello World. Here we have the program.cs file that we create, that is the name of our class. And there will be situations where you'd have more than one class, and all of these things would be down here. They will all be written down here. When we get to classes, we'll take a look at that. You see that the different class files would be written underneath the project, and there are situations where we would have more than one project in a solution. So now one question that I'd like to answer is that these files are not somewhere that we don't know about. These files are contained in our documents folder. So if I go to my file explorer, I go to documents, scroll down. If you install Visual Studio, this is the default location where you can find your project files. If you change this location during installation, I don't think you even changed that during installation, this is where it will be till you change it, sorry. So if I click Visual Studio 2013, go to project, look for my project. I have a lot here, so say Hello World. Here I can see I can see my solution. I can see my program file. Let me open it in Word. And here you have the same code that was written here, written in a text file. I go back, I have a project file which contains my project. Then I have these here, the properties, the objects, the obj, and the bin. The bin file either contains our debug or our release folders. At this point, I don't have a release folder because I haven't run my application in release. So the main difference between the debug version of your application and the release version is the fact that the debug is running in the context of Visual Studio. It's not something you would like to give away to another person. If you were to give your application to another person, you would like to create a release copy of it. And if you're using Visual Studio 2013, you can easily see at the top here that you have debug there. When I click, I can easily change it to release. Then I'll run my application. It runs perfectly. I click close. I come back to this bin folder and you can see that the release folder has been created. I don't even need to refresh. I click release and the release copy of my application has been created. So if I want to run my application, I just double click it and hello world is displayed. So whenever you create an application, you would advise that you create a release version of it, so that when you're distributing it, you don't distribute what you used in creating your application, like the other parts of your application that you don't want to get out. Now let's go on. Okay, let's do this. Let's take a brief overview of Visual Studio 2013. In order to be comfortable when you are writing your application, you need to be comfortable with the integrated development environment. So as you can see, I can click here and I have a toolbox window pop up. I have a solution explorer here and I have the properties window here. The toolbox and property windows are used primarily when building applications that require a graphical user interface, that is a GUI as people call it, so that you can easily drag and drop buttons, labels, and other visuals on your design surfaces and easily configure what they do by setting their properties. As you saw earlier, different contexts will bring up different windows in our IDE. When I run my application, you can see that a different context is brought up. I can see my locals. I have things here, my autos, locals, watch one. I can have my breakpoints windows here, my immediate windows here. And these contexts differ according to which part of the application you are working in. That is, we have the design time context. That's when we're writing and defining what our application does. Our debug time context, that's when we have our locals, our watch one, our breakpoints. And our compile time context, where those short has its own windows that pop up. So at this point, I'd like to also show you something called breakpoints. Imagine you're writing an application where you want to, and you're having some kind of problems. You need to check what values are contained in your variables. We haven't got into variables yet, but there's a way to easily stop the execution of your program midway, and this is with the use of breakpoints. Let me go back to debug. So in order to add a breakpoint, you can easily, there's a window here. I don't know if you can all see it. It's a little different from the general color of my IDE, but if I click it, a red circle is put on that line of code. This is one way of adding a breakpoint to your project. Let me undo that. Another way is to go to the debug menu up here with your line selected. Go to the debug menu up here and toggle breakpoint. At this point, we've put a breakpoint at console.writeline.hello world. If I click to run my application, you'd realize that the application stopped running at this point, and you can see from the console window that this line hasn't been executed. This line to show onto the console the words hello world hasn't been shown to the console. This is the use of a breakpoint, and we're going to use a method here to step over the code. That's to move from one point to another in the code. We have three different types of doing this. That's the step into, step over, or step out. We are going to use step over, where we'll just go step by step. I'll give explanations of these concepts later. Right now, just know that we're using step over for this activity. So when I step over, it will move one line down. You can see the yellow arrow point showing that we're on the read line part of our code. And when we open the console window, we see hello world written there. And that's the function of breakpoint. There are other demonstrations that I'll give you as we go on with this lesson that would give you a better idea of how to use breakpoints. Okay, let's stop executing. Now, we will have to, when you're writing code, sometimes you need to make a note to yourself. Say there's something you have to do, but you haven't done it. Or there's a code block you wrote that's supposed to do something, and you'd like to remind yourself later of why you did that. Or you're giving your code to somebody and you'd like to explain to the person why you did what you did. And a good way to do that is commenting. So to comment, there are about 3 ways to comment your code. So to write a simple comment, you just / twice and write this is a comment. A comment is not executed as part of your program, so you can easily write that I was trying to display text to the screen in order to explain your code. Commenting is a very good habit that you should all adopt, because you can, this is from experience, you can write several lines of code. You come back 1 week and you try and figure out exactly what the same person who wrote this code was trying to do. And it helps to have written notes to yourself that, oh, so this was what I wanted to do. Oh, I did this wrong. I did that wrong. Commenting helps in that way. Another way that commenting helps is that you're writing your program code and you realize that something is not really working for you, but you don't want to delete it. You want to have it, just let it be there so that you can refer to it later if you're stuck. So you can easily comment that line of code so you don't have to delete it. It's not good to delete code that you've written, because sometimes you need to go back. Something would go wrong and you need to go back, and if you deleted your code, you don't know exactly what you wrote. So a very good way is to comment out that line of code so that it's not part of the execution sequence. You can also use a multi-line. This type of comment, the double / comments that entire line. But what if you had a code block that you wanted to comment out? So in order to do that, you type a /, then go to the end and put / there. So then all the part contained between the / asterisk is commented out, and that's how you use a multi-line comment. Another way of commenting is by using the comment button. So if I want to comment all of this, I just select it and I click this button up here that says comment out selected lines. So I click it and it's commented. If I want to uncomment it, I just uncomment it like this. Secondly, I'd like to talk about customizing your IDE to suit your needs. This black environment here was set by me. Usually people like to go with the white one, the white side. And I'd also like to have line numbers here to actually, so I can easily refer to some segments of my code. In order to customize your IDE, you go to tools, you go to options, and here you have a lot of things that you can do. But for my line numbers, I'll go to text editor, click all languages. You can set your line numbers for specific languages, but then I want line numbers for all my languages. So here I'll go through what's available and check line numbers, click OK, and now I have my line numbers here. So now when I run my application and there's an error, click no, I can see that a semicolon is expected and it's telling me that it's on line 16 of my code. So when I'm looking for it, I easily come to line 16 and I realize that I didn't add that and click OK. Another cool feature of Visual Studio is Intellisense. Take a look at this. If I start writing console, you realize that it judges what I've already written and provides a list of possible things that I want to write. And when you find what you want, like it's already selected that I want console, you can use any, give me a second. You can use any terminator to continue. Say after console, I want a parenthesis. After console, I want a dot. After console, I want something else. So immediately you see that Intellisense has suggested what you want. You easily continue with what you would write after console. So console dot. You realize that console has been written in full, and I want right line. Since I see right line there, I easily open right line here. I easily open the parentheses and it writes that. Then I put in my pair of braces and I quickly write, this is Intellisense. I end it. So Intellisense helps you write code faster. It helps your code, it helps save a lot of time in writing all of console, writing all of right line. So if I'm even to write concatenate it and I want to write, I can just go to write and I have every other option that's available to me. Intellisense is good in a way that if say you're writing a line of code that you don't really know the available methods that you could use with the console class, you can change it here, say console.background color. Oh, I can do this to the console. I can set the foreground color. I can do a lot of things, provided you don't know there's something you want that you're not sure about. Intellisense can easily help you see that you can easily choose it. So here, I think it should be fine now. Yeah. Now there's something called code state. If you have code that is yet to be saved, say you opened your project and you worked on it and you haven't saved anything, the code state will let you know that you haven't saved this part of your code. This is what you changed and you haven't saved it since you opened your project. You can see your code state in two different ways. First of all is a little asterisk that would be present in the tabbed area next to the file name. If you see that asterisk there, it means that you are yet to save your code, so you need to save it if you want to save your stuff. Secondly, you would see this yellow strip excuse me, you see this yellow strip to where you made your changes. Remember, I did a lot of console.writeLine, console.this, console.that here. So it's telling me that from this point to this point, I've done things that I haven't saved. So if I am to save it, realize that everything here becomes green. If I am to close this project, open Visual Studio again, and open Hello World. You see, Hello World has been brought in my recent file, so I just click Hello World. You realize that I have nothing here, and if I begin to write another thing, say console, you realize that this yellow thing has already been brought there, meaning that I have made changes here that I haven't saved. This is a very good way of tracking what you've done. Sometimes you're working and you forget to even save your code because you're on a roll. This would be a very good way to remind yourself that you need to save your code, so that if your computer dies on you, you know what to do. So now that we've done a lot of this, let me comment this out and get to declaring variables and assigning values for duration. Now we're going to go on with variables. So think of a variable as a bucket in your computer's memory to store values. In order to store either, I don't even know how to go about this. It's used to store information in your memory. So it's a bucket that contains whatever it is that you're putting in there. We can create variables to hold specific values, be it dates and times, strings, big numbers, integers, etc. Let's go about creating a variable so you see what I mean. So I'll click, I'll do int. I want to create an integer and I want to call it x. I'll create another integer and call it y. And this is called declaring a variable. Int x, int y. So I want to initialize them now. I want to put values into them. So I'll say x is equal to 7 and terminate the statement. Then I want to say y is equal to x plus 4. So here I write my console. I want to display this to the screen. I want it to display y. Then let me run this and see that it will display 11. So variables would store these values so that when you're ready to use them, you can easily go ahead and use them, take them from their memory locations. So now after writing this, y now contains 11. That's from the value of x and the value of y. I always put this console.readline so that it will allow me to see what my program is doing before it exits. Say I comment this line of code out. Realize that if I run my application, it will just come and go away. It doesn't stop. So this read line says that if enter hasn't been pressed, or if return hasn't been pressed on the keyboard, the console shouldn't go away. So the moment I hit return, the application exits. We can also have, let me comment this out, other types of data, that's a string. So we're going to create a variable of type string that we're going to call my first name. I want my first name, see Intellisense here, Intellisense, sorry, to contain my name. And it. Then I'd want the console to display this. So I've passed the variable into our method writeLine, so that this is displayed to the screen whenever the application is run. So readLine, click start, and my name has been displayed on the screen. The way we've been declaring and initializing the variables here takes time. So there's a simpler way of doing this. So during declaration, we can easily do string my first name is equal to, and that easily does the same thing. So writing those two lines and writing just this one would give you the same results. So in naming your variables, it is advised that you use the right naming convention. That is, name your variables what you want, but you should use a naming convention called the camel case, where we start with a lower case letter and every other subsequent word in your variable starts with a capital letter. That is my first name. My starts with a small letter, first starts with a capital letter, name starts with a capital letter. And I'd also like to stress on the fact that you should name your variables well. That is, if your variable is adding more fuel to a number, right? String add fuel, so that when you're looking over your code later, you can know that, oh, this is the add fuel variable. If you go about naming them X, Y, Z, W, A, X, K, whatever, you'd get to a point you don't know, what was K doing? What was L doing? So it's better to have a very good name so that you easily can refer to them when you need to. Now, there is another thing that I would like to talk to you about. There's this other keyword. There are int, string, char, a lot of other keywords that describe data types for variables. But there's one in C# that really does everything. If you write this keyword var my second name, var keyword here would automatically judge what your variable is by the value you passed in it. So you don't need to specify if it's if it's an integer, if it's a string, if it's a char. You don't need to specify, just pass the values into it and C# would automatically judge what it is and use it. So here I've passed my second name and it's a string, but we didn't tell C# that, but we're still going to start the application and it's going to concatenate my first name with my last name. If I go to locals, Let me put a breakpoint here. Let me stop this. Put a breakpoint here. Start it. Stops here. And here in our locals window, you would see that my second name has been set to type string, even though we didn't set it to type string, even though we used the var keyword. If we hover over it, you see that that is a string. If it was an integer, if we hovered over it, it will show that it's an integer. And this is another function that you could do when you're using breakpoints. You can easily come over here and see what your variables are doing or what values they're holding at which point. Now, let's stop this and move on to type conversions. Sometimes you would want to, you declared a variable as an integer, but you'd want to convert it to a string to fit something that you're doing. Let's write these lines of code before. Okay, this lies a variable here. Let's say this. So string my first name can look nicer. In using strings, using strings, the addition sign adds concatenates one string with the other string. Concatenation is adding two things, just bringing two things together, not making them separate, bringing them together. I would display this to you shortly if you don't get what I mean right now. But here we have a string being added to an integer. This shouldn't be possible. But then if we run our application now, we realize that 7 has been concatenated to Akuoku. This is what I meant by concatenation. It will add the two variables or the two values that you are trying to bring together. That's what addition does when used between strings. But you'd realize that how was it that it was able to add a 7 to a string? This happened because the x here, the integer here, was implicitly converted to a string. The C# compiler noticed that we're trying to put this integer here into a variable of type string, so it implicitly converted the integer here to a string. Now, if I were to do this the normal way, explicitly, I'll add, to change this integer to a string, I'll add the method toString, which is a method available to all integers, and it gives integers the ability to be changed into strings. So this also works the same way. Nothing has changed. I'd like to stress that you don't want C# to implicitly convert your stuff for you. You would like, as a programmer, you'd like to stay on top of your code. You don't want things to be happening behind your back. So this part of the code was happening when we didn't specify. This part of the code was happening without us knowing it. So as I said, when it can, the C# or the .NET assembly will do your conversions for you, and you shouldn't rely on these conversions because they can give you a headache. At some point you're trying to do something and it has converted your stuff to something else. So take control of your code. So what do you think would happen if we tried this the other way? Let's say int my second try. I'm trying to add x to y and try and put it in an integer. How is it that they're going to put a quote and change a quote to a number? If I click, realize that it tells me that there are errors, and in the error it will tell you that it cannot implicitly convert type string to int. There's no way that a quote is going to change into a number. If ever we find a way that can happen, I'm sure the world will turn upside down. But we can't implicitly change a string to a number, but there's a way around it. There's no way you're going to be able to change this. So let's change this to say 5. 5 here, I can easily change 5 to a number and it will work in this scenario. But for us to do that, I need to do something very freaky that some of you will not understand. But see what I did on this line. Since by converting this 5 to an integer, I can easily add it to another integer, I can write this line of code like this. And don't worry about this int.parse. You don't need to worry about it at this point. It's just think of it as something magical that I'm doing. Anyways, so with this, I'll click start, and you see the difference. In my first try, we're concatenating the 7 with the 5, which gave us 75. But in the second part, since we're putting it in an integer, it added the 7 to the 5. That gave us 12. Now, I'm going to show you another way in which we can use readline. Sometimes in a console application, you'd want users to be able to enter values. Let me comment this out. You want users to be able to enter values for you to use in your computations. So if I start and write console.readline, now I'm going to initialize a variable here called user value. I'm going to set user value to here we're setting user value. We're setting user value to contain the readline method. Now let's say typed, concatenate the string with user value. Now, initially I told you that readline is used to terminate our application after we view it, but then you can also use it to accept user input. Let's see this in action. Click start. Please type something. And realize that it gave me back what I wrote, which means that it accepted what I wrote into the user value variable. Then it passed this variable into my console.writeLine. So this is being passed back to me. You type this is fine. I click enter and it exits our application. Next, we're going to talk about branching with the if statement and the conditional operator. Sometimes, at some point, you need to make decisions with your application. If a condition is met, you want a certain block of code to be executed. If that condition is not met, you don't want it to be executed. And we use if statement, decision statements to do that. So let's type in something very quickly. I wrote what is find your number 1 or 3. And with user value, string user value, set input from the user. Then now I'm going to start with my decision statement. If user value is equal to 1, I want my application to display Notice here that I didn't use just the equal sign, I used the double equal sign. The single equal sign is the assignment operator, and this one is used to check equality. So this statement here is evaluated to check if the data entered is equal to what is expected, and if this is what is expected, you execute this block of code. Then I brought this here. Let's copy this. Let's execute this thing and see. If I press 2 and press enter, my application would exit because I didn't take care of the instance where 2 or 3 was selected. But if I choose 1 and press enter, you see that I got a DAC will be displayed before my application will exit. So now let's add a bit more flesh to this. In order to test all other situations, we use a statement called else if. Else if always comes after an if. So if this statement is evaluated and it's true, it's false, I want you to make this check. Paste a bit. You got it. We have, let me change this to 4. Sorry, 3. And you got the car. Now we would want a default statement when if nothing else was chosen, else execute console. Now let's run this and see. If I choose to, let's run it again. If I choose 7, okay. And this runs perfectly. So at this point, you realize that we have the options to choose. When I was learning how to write a program, I wrote a simple decision game based on just if-else statement. So it's a game, it's a story where you get to a road. Do you move left? Do you move straight? Do you move right? You can easily do that using if statements. This code I've written here is clumsy because I'm writing the same code over and over and over again. That's the console.readline. And when you realize that, you need to refactor your code so that it makes things easier for you. So to do that, let me see. Okay, initialize a string here that says let's initialize an empty string here. Now I realize that I have console.writeLine and console.readLine everywhere, and it's clumsy. So let me copy all this. Then let me pass this. Mistake here. Put the message. Now I'll make page is equal to doc and the state. See what I'm about to do here? I'll copy all of this and just drag it up here, and it's moved there. That's another neat trick. Get rid of this. So do the same. You can copy and paste too. That works too. Let's do this for the last time. Yeah, so now we just change the value of message and just write console dot write line and console dot read line just once. And if we check, application still runs. And I see I can still do some work on this to make it simpler to look at, to read. And whenever you have just one statement underneath an if or else statement, you can ignore the curly braces because it's just one line. So you don't really have a code. You don't have a code block. You just have one line. So this can easily go under. I tidy this up a bit. Quickly do this. This ID. Yeah. Now everything looks tidy. Click start. So by refactoring, we improve the quality of our code. We make readability better. We don't waste space. We make our stuff look good so that when we are looking at it, we don't suffer, because you can really suffer by looking at lines of code. So one thing that you should have realized that I keep doing is when I write a little, I execute a little. This is a very good practice that you would like to adopt, because imagine if you wrote 50 lines of code and you are now coming to test it. You wouldn't be so confident in your code because you don't know where the problem might arise. Maybe there's a problem that would from the top that would affect everything that you've written and you'd have to rewrite. So you write a little, you execute a little to make sure your things are working perfectly. There's another thing that I'd like to talk about. That's the condition operator. This if statement, imagine if you had just two things to compare. That is, if it's not this, it's this. There's a very easy way of using it by using a condition operator. So say, let me comment out. Let me comment out this side. String message is equal to so if user value is equal to 1, return strand of length. This looks a bit clumsy, but I'll explain it in a bit. Message. Now, what I did here was that this is an either or. If it's not A, it's equal to B. When you're comparing two things, you can just use a conditional operator if you don't want to write a lot. So here on this line, the user is allowed to input. Then here, if user value is equal to 1, you take both. Else any other thing would be a strand of hair. So either this when it's true, or this when the condition here is false. And here in our console.write line, I'm doing something a little fancy here, but it's called string formatting. And this is the insertion syntax. And we use 0, 1 to denote positions. That's in the 0 position, we're putting the value contained in this variable. And in the second position, that's the 1, we're using the value contained in this variable. So if we click start, so if I choose 5 and press enter, you selected strand of hair, and this is what you typed, 5. Let's run it again and choose enter. You selected both, and this is what you typed, 1. And this runs smoothly. We easily check the logic here and display what needs to be displayed. So statements are complete thoughts in C#. Statements are made up of one or more expressions. Expressions are made up of operators and operands. Example of an expression is console.writeLine. It's made up of operands. Operands are like nouns and operators are like verbs. So this dot here is an operator that's working between console, that's allowing us to access WriteLine that's from console. So these two are operands. These two are operands, and dot is the operator, which makes all of this an expression. And statements are made up of one or two expressions. Let me explain that further. So the parentheses here is a method invocation operator. It allows us to invoke a method. The dot is also an operator, as I told you. So this is a statement because it's a complete dot. We are initializing x. We are declaring and initializing x to 0. This is a complete dot in C#. This is also a complete dot. So this is a statement, and we have a lot of statements. So I know I have talked about some operators, but this is some of the operators you'd be using a lot in C#. That is the assignment operator, that's x is equal to 3. The addition operator that adds 2 values. The subtraction, the multiplication, that's the asterisk. The division. This is the equality operator we saw when we're doing our condition checks. This either returns a true or a false. If it's true, the code here executes. If it's false, the code is skipped and we move on. This is greater than or less than. It either returns true or false. These are conditions, conditional operators, either less than or equal to. And we have here the conditional AND operator. Sometimes you have to make 2 checks. Either this statement is true and if this statement is true and this statement is true, execute this line of code. If this statement is true and this one is false, the whole statement is false. That's the trick with AND. If one is false, everything is false because both conditions weren't met. But then this is the conditional OR operator, where if either this is true or this is true, would return a true. That means the code here would be executed. So if the statement evaluates to true, the if statement will be executed. It doesn't need all of them to be true for it to be true. Now this is the conditional one we saw earlier, where if this is true, this will be used. If not, this will be returned. And this is the member access and method invocation, using the parentheses in here to invoke the method, and the dot in here is used as the member access. So that's all with statements and expressions. These are some of the things you'd be using extensively when you're building your applications and learning C#. So with something like this, you can't do x plus y and leave it at that. This is not a complete dot in C#. So be sure to know that. You need to know the rules, and VS would let you know that this is wrong. You can't do this. So you can't even do it. To tell you something is wrong. Let's try and debug this. No. Only assignment call increment and new objects can be used as a statement. This can't be used. Now let's move on to iteration statements, primarily the for loop. Let's go back here. Let's comment all of this out. Or better still, let me just open a new project. Create a new project. Sorry. For loop. So there are times you're going to need to go through a series of items or loop through a series of statements and perform some computations of them until a condition is satisfied. And to do this, we're going to use a for loop that helps you loop through a series of numbers or statements till a condition is satisfied. So in order to write a for loop, there's an easier way of writing a for loop, but let me show you the hard way before I show you the easy way. For open parentheses int I is equal to 0, white line, yeah. Okay, here in the for loop we have the assignment call, the condition check, and the increment operator. Whenever you see I++, it means that this is also written by I is equal to I plus 1. So by not wasting time to write I is equal to I plus 1, we use I++. We also have I minus minus, that's decreased by 1. So what we're telling this for loop to do is that it should move from 0 to 9, and every time it should increase the value by 1. So when it loops through this, it will write to the screen the value that's contained in I, that's 0. Then it will come back and write 1, and it will go back and write 2 till this condition is no longer true. It will keep running. Let's try and view this. And here, as you can see, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it has looped through this thing 10 times because it starts from 0 and goes to 9. We hit the return and we're back. And this is a very good explanation for a for loop. I didn't need to bring this to string here. It's superfluous. If I remove it, it still works because console.writeLine also accepts integers as parameters. So I click start and it still works either way. Now we can also do something interesting with for loops. In a for loop, I can easily put an if statement in there. I is equal to 7. I want you to write console. Comment this out. We're going to use a break statement here. Let me see. Okay. This is not a very good example, but it fits for what I want to show you. In this application, in this code we've written, get rid of this. I am looping through from I is equal to 0 to 9, and when I am doing that, if I ever reaches 7, I want it to display to the screen that it's found 7. And with our introduction of break here, this for loop will exit and it will come to this part of the code. If I put my breakpoint here and run this application again, you'd realize that at the first point, I was 0, as shown in the locals window here. If I hover here, you see that I is equal to 7 evaluates to false on our first run, and I is also 0 here. So by clicking this, I can easily pin I here so I can see the value of I as I step over it. So as I'm stepping over, you see it moves here, increases the value to 1, comes here, checks. If it's false, it goes back, and this continues till we get to 7. Notice that the value of I changes here and also changes in the local window. So let's step over it. I is 5. I is now 7. So when I is 7, notice that we will now enter the if statement, check the condition, then it will enter the code block under the if statement, then evaluate. Let me see our console window. It's not there yet. When we step over it again, you'll see that found 7 will be in our console window, and now it's on the break line. If I step over again, usually it just comes here, but when I step over again, it will go to the console.read line without having to evaluate till 9. So the break statement will allow you to exit a given loop or a given block of code if a condition has been satisfied. If you want to exit, you can use a break statement to do that. I hope that's clear. Now we wrote this for loop using the long method. There's an easier way of doing this by using code snippets. So sometimes you might forget the syntax for a for loop. Note that here we have the statement terminator here. That's the semicolon. We have the semicolon here, but then after I++, we don't have the semicolon there. People usually forget. I, for one, have forgotten a lot of times. So what I do most of the time is type in for, hit tab, and you realize that my for loop has already been written for me. Then I use tab to navigate the things that can change. So for the index, that is I, if I change this to my x, hit tab, you realize that my x is also changed here for me. So I'll choose 10 here. Then I'll hit enter, and it takes me immediately into the body of the code for the for loop. So console.line a for loop easily written, but I realized that I'm putting this for loop inside another for loop, and that would just give me problems later. So let me just cut this out and put it here. So I just click start, and I have found 7, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember that we put an if statement here that exited the loop when it found 7. And that's a very easy way to write a for loop without having to keep that in your mind all the time. And as time goes on, as you become more used to the C#, you know that code snippets will come easily to you by hitting tab twice when there's a snippet. There's a snippet for a lot of things. Say I'm typing else, I'll tab, and it will open an else statement for me. I don't want that now. Next, we'll go on to talk about arrays of values. Let me open a new project. Let's call it. Yes. So think of an array as a variable that contains storage locations for other variables of the same type. That is a bucket of data that contains other buckets of data of that same type. Another explanation is a sequence of data where you can access its members given its index or position. The good thing about arrays is that even though it contains other values, you can easily reference them when you know their position. Now, let's quickly demo an array. For the array creation statement is to create an array, you need to write this. Creating an array of type int, then we use a square bracket, then we write its name and write numbers equal to new int of size 5. I'm doing assignment and declaration in the same line. So I want to create an array called numbers, and I want this array to be of size 5. And take note that arrays are 0 based. That is, the index always starts from 0, not 1. So if we have an array of size 5, we will move from 0. The locations available for us to store data is from 0 to 4. Let me quickly show you this. So if I want numbers, equal to 67. Let me just copy and paste this. Don't copy and paste. I'll tell you the reason why. So, equation 1, 2, 5, 78. Now, I used array location 0 to 4, and there you'd realize that our array is of size 5. We have 1, 2, 3, 4, 5. And if I write line, wanted to display numbers, wanted to display the number in the third position. I'm demonstrating how you can reference the values in your array using the indices, sorry. So I click start and realize that it's 34, as 34 is contained in position 4. That's the third, the index 3. Now there's another way of initializing and declaring a variable where you don't have to do this. So let me comment this out so I show you briefly. Don't worry, we're almost done. We use this to show that we want to put in our values right after we declare the array. This is also another way of declaring an array. With this, you can enter all your values without having to specify the size before you start entering your values. So here I'd do this, and I can write this. Then I'll start, and to show me that 8 is in position 4. 1, 2, 3, 4. That's the same thing. Now, the square braces represent the index access operator, and arrays and iteration statements are most always used hand in hand. Let me show you what I'm talking about here. Let me put a for loop here. For I is equal to 0. Here I'm going to use a method called length numbers. Sometimes you wouldn't know how many values are stored in your array, so we use the .length feature to go through our array till we get to the end. So we're moving from 0 to the value just before the size of the array, and in there we want to Control X here, display everything in the array. This is a simple implementation of using a for loop to go through everything in your array. If you want to display everything, just go ahead and display it. And here we have 1, 4, 6, 8, 9, 7, 56, 45, 78, and so on. You can have an array, that is of type string. Let me comment this out. Text string, sorry. Bob, Sarah, and here we would use for each. A for each statement goes through a loop of strings. It's used for mostly for a loop of strings, and it simply iterates through your code block once for each element in the array. You see this string name and names. Sorry. Yeah. So now what I'm saying in that is that for each string name, that's a variable we are declaring in the for each statement. In names, display all the names that are contained in this string of array, this array of type string. And the for each statement easily allows you to do that. So now here we have Bob, Joseph, and Sarah. We click close, and that's the power of the for each statement. You can use it extensively when you're working with strings and other things and other concepts, which we'll get into in the second part of the fundamentals of C#. Now, when you use arrays, there are a lot of built-in features and methods available for you, such as the array.reverse method. Let me quickly take a look. Let's take a look here. Let me comment this out. Let's see. Fox. This is a popular text that most of us got to know about when we were in primary school, so I'm going to use that here. So we're going to use the variable type char, and as I said earlier, if a string is a sequence of letters, a char is just a letter. So a sequence of chars make a string. So a char holds just one letter, that's alphanumeric. So we want to create an array of type char and call it char array. We want char array to contain my text, that's a string, but then we want to use an array method that would change this string into characters and put them in the char array. And so we have a method called toCharArray. Okay. We have a method called toCharArray that would do exactly that for us. So now we've converted this text into an array, and we've put that into an array of characters, and we want to reverse everything in this array. So what we'll do is array.reverse brackets char array, and that. Now we've put everything, we are reversing everything contained in this array of characters. So we're reversing the order. So we are, the one which was first is now the one at the last point. So now let's use a for each statement. For each string boy in char array, I want you to show me right line boy. And I seem to have an error here. Sorry. Yeah, it needs to be of type character. If I didn't want any trouble, I could have just used var here. This is one of the advantages of using var. So if I click next start here, oh sorry, this is displaying it. As you can see, it's the quick brown, but this is not exactly what I want. I want this to display in a horizontal manner. So instead of using right line, I'll use right, which won't start a new line after each one is written. So here we have the quick brown fox jumps over the lazy dog, written in reverse. Now let's close this. And we'll then go on to our last topic for today. That's calling simple, using helper methods and calling simple and overloaded methods. So let's go to new project. Let me type in method. Okay. Now, a method, as I said earlier, is a block of code given a name so it can be executed by calling its name in another block of code. That's let me go over it again. A method is a block of code given a name so that it can be executed by calling its name in another block of code. And methods are important because it's one of the basic building blocks when you're building larger applications. So the main method here is a method that is triggered every time an application is executed. So let's take a simple demonstration of using methods and calling methods. Here we have string my value, an empty string, dot right line. This is a wonderful thing. Console. Yeah. So now I'll come here. This is the code block for our main method, and I'll leave this code block and come here and write private string. I want my method to be of type string, and let's call this super secret. Sorry, this is an error. Then here we're going to put in what our method does. I want our method to return hello world. now that I've written my method here, I can go here and assign this string value to super formula. Realize that this is giving us an error, probably because, oh, I know, adding here, don't pay any heed to it, I'll explain it later. But then if we add static to this, we can easily call this method here. Let me see if this runs. Hey, hello world, our method is called. So this is what we were doing. Now we can have this. This is a very simple code example for methods. You can have this calculate your temperature and degrees Celsius, from degrees Celsius to Fahrenheit, make some conversion. Say convert the Ghana cedi to $1. Have it do everything here and simply call the method in the main method for it to execute. Imagine if you had written thousands, like 1,000 lines of code, and you didn't use a method to calculate something like your degrees to Fahrenheit computations, and you have to go and look through your code to find it. That would be very tedious, because if you used it more than once, you'd have to look for every instance when you need to change something. That's where methods come in handy. That's where the whole object-oriented paradigm comes in handy, because it helps you easily navigate and maintain your code without having to go through everything and change something that might be working and make it not work. Now, the main reason for using methods is that one good reason for using methods is the fact that it's always a good idea to never have to write the same code twice. Copy and paste is the sworn enemy of every software developer. If you find yourself writing the same code you already wrote in some part of your code, stop there, go back and write a method for that function, because with a method you can easily change its function without having to change it everywhere. Once you change it in the method block, it is implemented everywhere you call that method, as opposed to writing the same thing in one class and here writing it there, writing it somewhere else. Now when you need to change something quickly, you need to change it in all those locations, as opposed to changing it once in that method. And that's object oriented. We'll get into that on Monday for our second session. Now, the concept of overloaded methods is that we can have the same method. Oh wait, I'm jumping the gun a little bit. Now, methods can take arguments, that's the input parameters, and a signature of a method. Let me take this again. You can have the same method with a method name but different signatures. What do I mean by signatures? Let me show you quickly. Let me just copy and paste. Now, this method, even though it has the same name, is different from this method. Why? Because this method accepts an argument that differentiates it from this method that doesn't accept an argument. Why am I saying this? Let me comment this out. And I'm getting an error here because there's no overloaded version of this method that takes 0 arguments. So for me to write this, I need to pass in a string and say Bob. Okay, just passing my name. And then in the method, I'd like to use the string. I'd just like to concatenate it with name. And if I run my code, hello world AK, you realize that I have this here. In the method is accepting an argument. We can change this and write int 5. And immediately I do that, I need to change this to also accept an integer so that it fits, int cat. Then I'll concatenate this. So you have hello world AK 78. Oh, I should have used 47. That works. Anyway, now I can uncomment out this code and my application will still work. So now if I am to call string my second value, great formula, and here you can see that they are saying that this super secret formula has one overload. It has an overloaded version that I can use. So let me just use secret formula. I want to use the very first version. So the signatures helps you differentiate the method that you're calling. So you can have the method with the same name but with different invocations. You can have a method called car type, then an overloaded car type with nothing, that doesn't accept any arguments, that just tells you the car type. Now you can have an overloaded version of the same car type method that accepts the name of the car. That is, if it's a truck, we want it to accept a string to show that this is a truck. Then we can have another overloaded version that accepts the type of car, its name, and the color. So with super secret formula, I can easily add an overloaded version here that just takes string name. See? And string name. So this method is different from this method, which is also different from this method. We'll talk more about methods on Monday. Right now we're over time and things up. So the third value can be assigned to a secret formula. And here you can see that it's telling me that I have two overloaded versions of this method that I can use. So super secret formula, once the version that takes in just a string, say boy. So now when I run my app, see what I did? I didn't display everything in here, so let me just and paste them up. Shouldn't make that your habit. My third value. Yeah. Let me write this. I think this works now. Now we have hello world AK78. Hello world, hello world. This has happened because I didn't change. Hello world 78, hello world, and hello world boy. This brings our lesson to an end. We'll get more into methods and classes in our next section. In our next session, I wanted to use this to give a brief overview of C#, what to expect. We'll get into the object-oriented part on Monday. I think we should make Monday's session 2